Thank you. So we're talking about now the bogey in the room, or the elephant in the room, whichever one you want to frame. So it's been talked about a lot in all the sessions yesterday and the session so far today. Arc flash and shock PPE. So first of all, can we have our first poll? So get your Slidos at the ready. I want you to be answering this poll that's coming up any moment now. So there you go. In practice, is arc flash PPE the last line of defence? So hierarchy controls, PPE normally sits down at the bottom or under the carpet. Is it in practice? So yes, 64%. No, I like these no's. These are good, these are. Everyone pop in the votes on Slido. So yes, if it is last line of defence in practice, or no, if it isn't. I know what Stuart Gregory thinks. I know what my three colleagues here on the side think. And at the moment, we're in the minority. That's a good start. Okay, so for everybody that has voted yes, that in practice it is the last line of defence, put your hands up. Okay? Come on, there's more than 62%. Put the yes in here. So hands up in the air if you voted yes, that it is the last line of defence. Okay? In practice, yes. Keep your hands up if you don't wear day wear arc flash PPE. Keep your hands up. Not many. Okay? Hands down. Thank you much for that. Okay, so first and foremost, the four of us on the stage right now, we are the firm believers, we're in the no camp. Stuart Gregory is also in the no camp. First and last line of defence. And today, we're going to talk in this short session now about why we believe is also your first line of defence. And I'm hoping at the end of this convincing presentation, you'll agree it also is the first line of defence. Next slide, please. And the next. Oh, sorry, I'm not used to this sort of stuff. There we go. So we may have some shocking content, flashing lights, explicit images, and we'll try and warn you as they come up. So first of all, answer along. Yes, thank you. I know, terrible, isn't it? So Anthony Long, Strata, Technical Director for Strata and Scanware. Strata, as you might know, you've probably seen our stand upstairs. It's our own in-house internal arc flash brand of PPE. We started our first production in 2015, so in February next year will be our 10th anniversary. So we'll try and raise some parties for that. And then alongside me here, I've got Graham Hogg, mentioned already, Martin Talbot, and Victoria Stevens Patterson. Okay, so we've done the poll, sorry about that. So arc flash, when and where they occur, and what are they? So arc flashes take place when there's a system, electrical system fault, or short, whatever you want to call that, okay? So when it occurs, sparks generated, oxygen in the air ignites. Does anyone do welding with oxygen? Okay? Or cutting steel with oxygen, okay? Oxygen is a really, really hot gas when ignited, and that's part of an arc flash, okay? So a huge amount of heat is generated, oxygen in the air ignites, it melts the copper and aluminum conductors, and anything else in the vicinity, and then ejects that away as part of the actual explosion itself as the air expands, and that then comes out as a mixture of heat and molten metal, which then often either causes burns or damage or destruction. But ultimately speaking, as we're putting on here, incidents create burns to skin if not contained or protected against. Arc flash PPE is designed to protect against these very burns that we're talking about. So this is a video here now. Many people have seen it before. So these fellows here, they're working on a system. They're intruding on a system. The system arcs. You might have seen the arcing in slow motion before in other videos. You get a massive amount of heat generated, and then you get a whole box of fireworks come out of that. That's your molten metal coming out. Arc flash PPE is doing two things. First thing it's protecting against is that initial heat that's generated by the arc flash itself. Second thing is the molten metal that's then ejected. Anyone here had any experience in steel works or aluminium works? Okay, a few hands, okay? So ultimately speaking, all clothing for steel and aluminium workers is category 3 PPE, designed to protect against life-changing injuries or fatalities. Because molten metal, aluminium, it sticks to fabric, it burns through fabric and causes really bad burns. So your clothing, for Alpha's PPE, is doing the same thing as well. It's protecting against all the molten drops as well as the initial heat. Okay, so bear that in mind, you've got two things going on there. Next video here, this is on YouTube. We've shortened this down to this very moment in here. He didn't even touch that. And he's wearing no PPE. That could be any single person in the audience today wearing the current clothing you're wearing now. You could be in the same situation as that gentleman there. Okay? Do you want to? So arc flash incidents can take place any time, whether it's live or potentially live electricity. We say potentially because loads of arc flash incidents happen when people think it's dead. And you know what? It's not. If every single person had a proving unit and used the proving unit, we'd be out of business, or possibly out of business, okay? But ultimately speaking, arc flash incidents occur. We carry out isolations, re-energization, fault finding, racking in and out breakers. When there's a system fault, so if there's a system fault, there's already a big issue that you need to be aware of. When the system isn't in normal operating conditions, so this is a term, normal operating condition, referred to in NFPA 70, I believe it came out in 2018 edition. And it's basically referring to something, if it is not in its normal operating condition, so basically, if you're commissioning something, it's not in normal operating condition. If you've not got a service and maintenance history, it's not in normal operating condition. So if you're a contractor like Graham Hogg, and you go to a site that's 50 years old, is that gear that you're going to work on, is it in normal operating condition? High chance it's not, okay? Unless you know physically yourself you've been maintaining the equipment. When panels or doors are open, this next one links into this, due to human error or incompetency. When the system is live, it's thought to be dead, or when you know it's live, it's supposed to be. If you know it's live and it's supposed to be, there should be a separate set of precautions working around that system itself, okay? So on here, one of the things we get, I see loads of pictures, panels and doors open, doing fault finding, system still live, and people are wearing polyester or polycotton, slightly better, clothing, okay? You've already got a door open, that door acts as an arc flash barrier, the system's live, and worse, you're meddling around when the system's already in fault. You're raising the stakes of an arc flash by 1,000,000%, okay? These slides here I'm going to go through now, they're all focusing on burns. So first of all, Steve's electric shock, clothing caught fire, he sustained serious burns to his face, chest, arms, hands, legs, stomach, medically induced coma, 2 weeks, etc. Next one, more burns, required surgery for recuperation in hospital for 2 weeks. Next one, 37-year-old, underwent multiple surgeries for the incident and required a skin graft from his thigh. Another one here, this is part of a discussion we're going to talk about later on, but again, this guy was severely burnt. Another one here, this one here is an interesting one. Occurred on the site, resulted in an arc flash and burn injuries to wind turbine technicians working to replace a faulty wind turbine 690-volt circuit breaker, and it was following the stations of work. Okay, still burnt. Battery storage, burns, works up a burn to his face, body after a crowbar I was using. Okay? PPE. Put your hands up if on your site you mandate safety boots to be worn on sites. Okay, that's good. Pretty much most of you. Why do you wear safety boots? Because they might get a crushed toe if something falls on it. They might get a puncture through the sole by stepping on something sharp. You need to have good slip resistance. You might have a boot because you want ankle protection. Okay? I don't want to wear those boots. I want to wear my friend here, Nike Jordans. It's a boot. Okay? Why can't I wear that boot, Graham? But I've never had anything drop on my toes. And also, I've got ankle protection. And I know this sole design is really good for anti-slip. So, I'm going to wear that boot. Is that all right? No? So we give people boots because they might have something drop on the toes, or they might slip and need some ankle support, or they might stand on something which might punch the sole. They're all mights, aren't they? We have people going to work with safety helmets on in case something drops on their head. But we see people working on roofs with nothing on top of them and they're wearing safety helmets. We send people to work with high-vis vests so they can be seen by all the traffic members. But we see people climbing scaffolding where there's no traffic, wearing high-vis vests. Okay? We put people on a regular basis, safety footwear, safety gloves, safety glasses, safety helmets, okay? But we still send people to work in an electrical environment where there's a risk of burns, as you've already seen, and we still send them in polycotton or polyester clothing. Why aren't we sending them in artificial clothing? We've talked the last day and a half about electrical environments and the hazards in an electrical environment. Is getting burnt more of a hazard than dropping something on your toe and breaking your toe? Okay. So, some important considerations here. So there's no evidence of anyone ever being killed wearing artificial clothing or electrocuted wearing correct insulated protection. Art flash doesn't mean you'll not get burnt, after PPE doesn't, but it will seriously reduce the chance or the likelihood of burns and how severe those burns are. And it's also a myth that artificial clothing and shock PPE is too heavy. Graham Hogg here, he wears his day in day out regardless of what he's doing. He even wears it at electrical safety conferences. Okay? But we can do. There's no difference, okay? So, people think of this when they think of art flash PPE. And generally speaking, this one I've got on here, that's on the slide here, is a really lightweight version. Okay, there's probably a lot in the marketplace, and I know there's a lot. In fact, there's a hood up on the stand at the moment, which has got half the cal rating of that, and it weighs about twice as much as that. Okay, so that's change. But ultimately speaking, people have that perception that is art for PPE. Okay, but is it? You could be wearing that, or what Graham's got. Okay, that's still art for PPE. Obviously, face protection, hand protection to go with that, but plus an overall, you're increasing your protection levels straight away. So if Graham decides to wear a coverall on top of his t-shirt and trousers, he increases the protection levels, hoods, face protection, gloves, and he's covered. So ultimately speaking, the bomb suit, as people often refer to as a space suit or Teletubby suit, if you remember those, they're seldom required in the main. Okay, when we do look at alpha studies, and we look at all the instant energies and alpha studies, and then we talk to people about their systems and how often they're actually working on these requirements where you've got over 40 cal or over 30 cal or 35 cal. It's not very often in some cases, okay? So then you'd ask the question, well, do we actually need those 40 cal suits? So we often get this question about this gear here. So that polo shirt and trousers on the left-hand side there is rated at 12 cal. The alpha incident energy was 14 cal. So he wasn't wearing enough protection for the actual arc itself. But you can see it's charred black at the front, but it's still in one piece. And that person wearing that will 9 times out of 10 go home, just feel a bit sore, like you've been sat out in the sun all day and got a bit of a sunburn, okay? This person here, straight to A&E. But first of all, someone has got to put this person out. Okay? Polycotton clothing in an art flash is just fuel. How many here know about burn, the degrees of burn, first, second, third, fourth degree burns? Many people know about that or not? First degree burn, like a suntan, second degree burn, blistering, third degree burn, skin starts to char, fourth degree burn down to your bones. Okay? The longer you're exposed to a source of heat, the deeper those burns go inside you, and the chances of survivals plummet. Stop putting people in electrical situations in this gear here if you wouldn't let them wear Nike Air Jordans to work instead of safety footwear. So ultimately speaking, if you're going to do that, would you rather work naked or wear polycotton clothing that burns? You see on this piece here, you've got quite clean looking skin here. The slide doesn't show it very well. Clean looking skin up here. This person was wearing a high-vis vest. And those are all the burns from the high-vis vest and this is the burn area, which wasn't burnt by the Harvey's best. So, if you're still wearing polycotton clothing and you work in an electrical environment, tell your employees to take that clothing off before they go anywhere near any electrical equipment, because your skin is better at coping with burns because it doesn't ignite than you are with clothing that does ignite. Graham.
Thank you, Anthony. Good afternoon, everybody. You might remember from yesterday. So, understanding, measuring, mitigating the arc flash risk. So what is the risk? Could there be an arc flash? Well, wherever there's electricity, of course there can be. How big, how powerful the arc flash be? What's the likelihood? These are all the things that we go through when we do. Everybody who spoke over the past day and a half has basically gone through all of those things. But there is always a chance that there could be an arc flash if we've got electrical equipment. So, what's the risk? We've got HV and LV, and I've heard a lot spoken about HV over the past day and a half, and yes, it's a high-risk environment, but when it comes to arc flash, LV is generally where you're going to have the larger available energy. Due to the longer tripping times, we've got a higher current, and for me, likelihood, there's a lot more LV gear out there. There's a lot more people working on LV daily, and most of the risks, most of the incidents you hear throughout the industry tend to be on LV gear. Certainly, what I come across, equipment that's undergone an arc flash is LV. I've seen quite a lot of HV bits of kit flash over before, but mainly LV, and it's lack of maintenance, drop tools, blah, blah, blah. Water leaking through roofs, things like that. So, choosing the right PPE. We've got three situations. Working on our area, existing electrical distribution assets. Martin is going to cover that shortly. Then we've got installing and commissioning. We touched on that yesterday, and I'll briefly touch on a slide that Joe was going to cover. And then we've got, we're a contractor working on somebody else's site, and that's basically my life. So, sorry, Martin.
Thanks, Graham. So I think I'm going to cover choosing the correct PPE when we own and operate our own site. I work for a data center operator. We've got 14 buildings. We have complete control over our own systems. We own and operate the building. We can control who accesses our substations up to 33 kV all the way down to LV. And Graham's completely right in that the LV is probably our most hazardous area. I think it's green because the best thing that you can do as an operator and employer is to have an incident energy analysis study done on your building, either whether your own engineering teams or an external consultant. Because then, as what you've heard from Anthony, is that you will get a more tailored solution for your team, the operations you carry out, and your own equipment, rather than the other solutions that you will hear. So that involves collecting all of your data, your equipment type, your maintenance conditions, and then conducting a calculation on it. So you'll get then a arc flash study, or an incident energy report, or an arc flash risk assessment, which are all broadly the same thing. And then what you really need to do is do some homework, understand what that report says, make sure you get it from a good consultant who understands your business and how you operate or you want to operate as an organisation, because then you can then tailor your PPE requirements, as was mentioned before. So we're not wearing bomb suits for everything, because it just won't work. What happens when I came into the business that I'm in is that 5 years ago, we were in completely the same situations where we were wearing polyester t-shirts and jeans to carry out switching operations. As you just heard, clearly that's unacceptable. So we took on the challenge of analysing all of our own buildings, and it's also within our standards that we have an arc flash study done as part of a new build. so that we know that it meets our standards. I think it was Mark this morning mentioned having a specification. And when you do this, it's really important to have that specification. So for example, ours is in substations that we completely control, we have a 40 cal limit for when you're opening up and proving dead, confirming dead within equipment. That's when the bomb suit's required. As soon as you've confirmed dead, you can take it off. So that 40 cal is really only worn for absolute minutes. And then within substations, we have a daily workwear. Because working in a critical facilities business, we have engineers on site 24/7. They need to react straight away. So having people to get changed is not good enough. We can't do it. We need them in the right equipment, ready to go at a moment's notice. So it's daily workwear for us. They're also already wearing uniform anyway, so you might as well make it arc-proof. Yeah, so you're going to analyse, you're going to document your findings, and then you're going to look at your assessment, and then basically build in the results of your arc flash report into your daily work routine. It also tell you what labels you have. I've got an interesting question actually, what you'd like to know about what you think about having the shock hazard information on here. My personal feeling is that I don't put it in. You'll see a lot of labels that were produced by software which come from American standards, which is the IEEE 1584-2018, and they'll talk about limited approach boundaries and restricted approach boundaries, which have no relevance to us in the UK. So you might see consultants pump those out because they're templates from software. I would encourage you not to use it because I think that adds confusion, but I'm open to hear your opinion on it. And then you've got the actual arc flash hazard on the left. So you'll get your incident energy report, which will tell you all of the incident energies that you could get on any part of your network. They'll be printed on your report, and that's how you can tailor what you're wearing when you're actually working or operating that equipment. I think that's me. Joe.
Thank you, Martin. So yeah, the second situation, we're installing commissioning equipment. This is a slide I'm picking up on, so bear with me. Arc flash studies can be obtained from OEMs. It's more on generators, things like that. So, and temporary labels possibly applied. So this is for equipment that's not connected to the distribution network at that point in time, and it comes off the shelf, and it's a known incident energy level. Then we've got my typical situation. So I'm a contractor working on somebody else's site, and not all the sites are going in great shape, as Anthony mentioned earlier about doors and things being open. Well, some of the situations I walk into, doors were obviously an optional extra when they bought the gear because they weren't in the switch room and they certainly weren't attached to the switch gear. And that's not LV. I've seen 3.3, I've seen 11 open and in atrocious states. So, and I've been called out some strange times of the year and some strange times at nights into these situations. So how do I put the necessary safeguards into place for myself and the guys who work with me? A lot of it does come through experience, comes through training. I'll touch on that a little bit. Also, there was a slide yesterday showing various documents from around the world, CSO, Z462, NFPA 70E, the German one, the European Arc Flash Guide. There's a plethora of information there that I can pick up very readily and start to take control of it. A room, a network, a system, and start to understand some basics of what sort of incident energy levels do I have. Also, as somebody mentioned this morning, we have supercomputers in our pockets. There is apps, there is information, and I can very quickly do very basic incident energy assessments with that, with very little data collection on site. A lot of sites, there's not a lot of data, as we've mentioned over the course of the past 2 days. Not always the system drawings available, things like that. So, and as Anthony mentioned earlier, putting something on that is not going to catch fire is better than putting nothing on. And we have, my company, we're a strong advocate of that. We're in daily wear, it's a uniform. It was very easy for me to start wearing arc flash clothing because I come from an oil and gas environment. So I was already in FR, I was already in anti-static, I was already in high vis. Yeah, it's just got another badge on this. So I was used to it anyway. And we're in daily wear, minimum 8 cals. We all carry helmets, visors, gloves, you name it. And if we're starting to get into some large energy systems, we're putting overall over the top. If I don't have them information, we just lay up. And Anthony can tell you, he knows what gear I carry. I can lay up to well in excess of 40 calories if I need to. So that's just some things, table methods, like I say, C462, very easy. Cross-relate that to British gear. It's not difficult to do. And you can very easily put a safe system work in place, use a point of work risk assessment or a job safety brief, and however you want to do it, and document what you're putting on, why you're putting it on, and you've got a record of why you've done that in a certain situation on a certain day. So it's to say why I've got my daily wear on or why I've put an overall over the top. And I've got a documented risk assessment, which has took me 20 minutes to do. Ah, right. So, so these are also some tables that are out there. This one is one of Canada's as well, and I carry a copy of this, and other companies put these together. And it tells you very quickly, you've got garments, what the combination is, and what levels you're going to start to get. Sorry? Lost my microphone. Sorry, I do apologize. Thank you. So, yeah, this tells us very quickly combination levels and what level of protection we're going to get from putting those different combinations of different PPE together. That's just another example. That's top garment, bottom garment, overgarment, gloves, boots. I've got boots on that one, balaclavas and so on and so forth. What level of protection that PPE is going to give us. So that's me. Thank you.
So electric shock. So we've talked about arc flash. There's a very open topic. What kind of protection do I need? So Graham and Martin very kindly talked through sort of situations there would pinpoint that. Electric shock, understanding the risk. Ultimately speaking, with electric shock, you come into contact with electrical equipment, it finds earth or will go across your body to another phase. And ultimately speaking, electric shock, we're still here today to talk about that. Electrocution, sadly, we're not here today to talk about that. But ultimately speaking, the risks of current interfering with the body is it will send your heart into spasm, heart attack, and cardiac arrest, okay? It's one of the worst things that can happen through electric shock. So ultimately speaking, we want to protect against that risk. And how do we protect against that? We have a really, really simple format for electric shock risk, okay? So we've got our voltages, we've got our class of gloves, or your amount of matting, you also have shrouding in there, for example. Ultimately speaking, gloves become our primary protection. So 500 volts, AC this is, obviously class 00 gloves, and up to the ratings. So ultimately speaking, it's very, very easy to protect against electric shock because you know the voltage, or you should know the voltage, like Martin said. If you don't know the voltage, you shouldn't be anywhere near the system. But ultimately speaking, you know the voltage, very, very quickly, you can protect against the shock level that the voltage is telling you it is, okay? So very, really easy, quick win when it comes to insulation against electric shock. But ultimately speaking, you've got to wear the PPE in the first place, okay? Skin isn't very good at offering protection. And then with that, I'm going to pass on to Victoria.
Press.
That one there.
Okay.
Yep.
Hi everyone, I'm just going to hold on to this for moral support. So my name is Victoria Stevenson Patterson, or VSP, and my role is varied, and one of my favourite things I absolutely love to do is go to site to visit customers and to learn about not just the risk but the environments that people are working in. And up until very recently, I used to class myself as an ambassador for ladies' arc protection. But I've actually changed my stance on that. I'm now an ambassador for inclusivity and equality because I believe, I'll put it another way, when I go to a site and somebody says, this is fab, I love what you're showing me, I love the samples, do you do ladies options? I say, yeah, because it's 2024 and we should do ladies options. We should do all options. Oh, this is Martin's slide. I've gone on to my little thing. You'll have to come back now. Sorry, Martin. So what we do is, and it makes me think, actually, we shouldn't just do ladies' options. We should do options for everybody, because a workplace should be a safe environment for everybody, and everybody should feel included. And just because there's an electrical risk, it doesn't mean they should be exempt from that. The fit of the clothing is absolutely paramount, and I'm just going to tell you a really quick example of one of the many visits I've done and many examples I've seen over my time. I've been travelling to site now probably for about 5 or 6 years, and one that always stands out to me is I went to a power station. I had 2 ladies there who'd been working at the power station since they graduated, and they were wearing, let's face it, men's overalls. You can sugarcoat them all you want and call them unisex, but they're designed for a man. And when I got there, the people who ordered the PPE, a man, had made sure that they had the regular leg option, and there was no consideration given for the fact that they're a different size, a different shape. So I went to see these girls at the power station, and I said, what's the problem? You know, how can I help? And they said, we're worried that our PPE is causing us to trip on a daily basis. We're worried that when we climb over, they had to do like a task where they climbed over a pipe to do a meter reading. And as they did that task, because when a woman, if you know, any women in here ever wore men's overalls, don't know, you know what I'm talking about, don't you? The baggy crotch situation, it's really flattering, really, really nice. Every time they climbed over to do the meter reading, the crotch caught on the pipe and caused them to almost slip. When they went to do the meter reading, the overalls they had were baggy around the hands, and they had to constantly roll them up. The trousers were gathering around the legs, and they had to constantly adjust them and move around. So the PPE was distracting them. It was causing them to be unsafe. So I put them into a really simple approach. I put them into a 2-piece option. They looked fantastic. They looked like they were smart. They felt proud of the brand. They felt proud that they were looking like the equivalent parts, just in a 2-piece rather than a full overall. 2 weeks later, I rang those ladies. Sorry Angus and Russell, I let them keep those 2-piece, free of charge, sorry about that, because I just wanted them to be protected. And 2 weeks later, I rang them and I said, how are you getting on with the protection? And do you know what happened? Their supervisor said, yep, you are protected. Yep, you're no longer tripping over the pipe. Yes, your hands are no longer restricted. However, you don't look like your male counterparts, and they'll complain. They'll want the same as you, so you can't wear them. And those ladies had to go back into the men's overalls. And I absolutely, to this day, hate the fact that they are still working in that power station wearing the wrong PPE. So I would say, and I said to them, is it in your policy and procedure, and why have they got to wear an overall? Why have you got to wear a 1-piece? And they could not answer me. And what I would say is there may well be a safety reason why a 1-piece is required, but I would challenge people to say, to get rid of that thinking of, because it's what we've always worn, because it's what we've always done, and push past that and let's look in 2024, actually, what's the safest option, no matter what gender you are, no matter what shape or size you are. Because when we're talking about equality, and we're talking about people having the right fit and being treated the same, it shouldn't matter. People shouldn't say to me, do you do ladies' PPE? They should just say, what options do you have available? And when I show them the ladies' PPE, it should look exactly the same as all the other PPE, just in a different tailored cut. So that might mean a shorter leg, it might mean an adjustable waistband, etc. So I'm in a really great position working for Scanware and our STRATA brand that we can actually manufacture products in quite a quick turnaround that cover inclusivity, and they take into account disabilities, body requirements, and religious requirements. So as an example, I'll just show you. Over my time working at Scanware, I've known us manufacture trousers for somebody with a prosthetic leg. I've known us develop our ladies range and keep on expanding that range and making it fit for purpose for all the different sites I go to, be that a power station, a wind farm, a data centre, a manufacturing plant. they've got options for those different ones. And just recently, I've now started even looking at PPE that's appropriate to faith. Because why should people be discriminated against because they can't get an FR or inherent turban or a hijab? It's 2024. Let's push the boundaries. Also, I'm really proud to say that we've been supplying a big and tall range. So we've now got options available for larger shapes and sizes as well. Because we shouldn't be discriminated. It should just be normal. We've got a solution for you. And that's it from me. So shall I go back to Martin's slide? Thank you.
Yeah, okay. So moving back, obviously what I was talking about before is having an incident energy analysis or an arc flash study. From that, you'll get your arc rating of your equipment, and therefore you'll know, because it's all in the same format then. That study's in telling you what the incident energy is in cal per centimetre squared, and the PPE is then rated in cal per centimetre squared. Don't be that engineer who just goes out to a PPE company, be it Scanway or not, and says, what do I need? You should know. Like, I want this rating for this equipment, for this job. What are your options? Layering, as they mentioned before, you can layer, and in fact it increases the protection because you get sort of an air gap between your layered clothing. Comfort and mobility, what areas are you going to be working in? Is it going to be a hot environment like we have in data centers? Quite often it is. Is it going to be working in cold weather environments? Do you need those different options? Because what you don't want is to have a mix of equipment. The polyester, which does happen, it's, been doing it for 5 years. Every day I could probably still go and see someone wearing a gilet, a bodysuit with their arc flash protection stuff. And then it needs to be stopped. It's a constant process of education. Yeah, guidelines for selection, as discussed. You can go to any brand, and as long as you're specific, you have a specification, and you go out to them, and they should be able to assist you with a range of options. And match it to the risk level, absolutely. And that will come from your risk assessments and your arc flash study. Making sure it's proper fit, inclusive for all, as Victoria mentions. And the first P in PPE is personal. So don't go through the route of hanging overalls and switchgear for anyone to use, because then who maintains that? Who washes it? We learned that from COVID, is that we cannot have multi-use PPE for different people. So yeah, it should be personal. Make sure that they know how to maintain it, care it, and replace it when it's warm. Thank you.
That's the ultimate objective. I think Stephen Rose mentioned in his speech yesterday morning, I've never heard him tell that story for those who were here, about when he set those new team to work, and then one was involved in an LV fault. I've never heard him mention that before. But ultimately speaking, he asked the question of people that have actually had to go and talk to somebody about an injured loved one in a hospital, okay? No one wants to have a conversation, realistically speaking, do you? Okay? So our intention is that everyone goes home safe. Surely your intention is everyone goes home safe. PPE plays a big part in that. We all make human errors. So it's making sure that if there is human error, you've still got all bases covered. We're not sending people to hospital burnt, okay? Thank you.
Thank you there. Real good presentation, that one, folks. Really good. Well done, Victoria.
Thank you.
Yeah, it's just supporting it. I use it to hide behind.
We can leave soon, can't we?
No, that's good. So we've got some Slido questions coming in on this one, but we've also got the microphones running around, so if there's any questions, look at that. We've got first taker. First taker.
Thanks for a great presentation, but after that presentation, do you still think that PPE is the first line of defence?
Yes.
Yes.
Do you?
No.
Why?
The incidents that you showed at the start, good examples of incidents to do with arc flash. I bet every single one of them could have been stopped and had nothing to do with PPE. The videos, every single one of them could have been stopped, nothing to do with PPE. I agree, everybody should wear PPE. I'm not saying that, but everybody should wear PPE because there is always the chance of the what if, yeah? But when you take plant and apparatus out of its normal operating condition, you are physically doing something, or you have exposed something, or you've not, it's not just in its energized state humming away like it should be. At that point, you've changed something and you need to manage a risk. Like I talked about earlier on with the hierarchy of control, we should look at de-isolating, taking that risk away. Every single one of them incidents on there, the risk could have been took away and they wouldn't have been reliant on the PPE and they wouldn't have hurt themselves.
Good question, Mark. Can I ask you, if you go to a wind turbine, or you wear a full rest harness,
Yes,
why do you wear that?
because I'm physically climbing.
And you can take the risk away. Why are you climbing?
Yeah,
Get a
and
lift.
it's the same question as, can we achieve zero harm? Yeah, of course we can. Because fundamentally you do nothing.
Don't do any work.
Exactly.
Yeah.
In
So
practice-
it's a risk. It's a risk-based approach from then on, isn't it? When you decide to do work, it's risk-based. But I think I agree we should wear PPE all the time for the what-ifs, because there is what-ifs, and
Yep.
we need to protect everybody. And there's loads of what-ifs where, oh, good job I had my trousers on, or I'd have cut my leg. But I think when you actually really look into the arc flash potential, most of the time, and those examples that you showed there, that people shouldn't have been reliant on the PPE.
You're not reliant on the PPE, but the PPE is there to protect you if something goes wrong, like
Yes.
footwear. So, for example, if you walk into a substation, do you wear slippers?
No.
No.
Yeah.
Why
wear
do
footwear.
electricians use insulated screwdrivers? They don't work live.
No.
Why do they use them?
Yeah.
So
It's
there's always...
the same what if.
It's all
We
those what if.
don't,
I
why
agree.
do I need insulated tools when
Yeah.
I've got a voltage, a proven unit and voltage indicator?
Yeah.
Yep, no matter on the voltage level, many flavours, many different types. If I've proved it, why do I need insulated tools?
Yeah.
I don't.
No, you don't. And if you took
It's because
if you'd
after-
isolated the panel, then you don't need insulated tools.
But
Same as if you'd
Everybody uses
isolate the thing, that's not saying you don't need arc flash, but it isn't your first line of defence, it's your second.
Things
Probably
always
the
don't
last
happen
line.
as expected, do they?
No.
no,
That's-
it is
that's
for the
thing.
what ifs, and it's like the gentleman said at the start, it's first and last within a context. Yeah?
Yeah.
I think I can jump in here quickly. So I think the proposition of the question, when we're actually running through it, I think we applied the in practice part. Of course, PPE is your last line defence. So every single consideration should be made to what can we do to mitigate. The whole purpose of this conference is actually to remove the risk of anyone being injured by arc flash. The simple question, it's a little bit of a funny question, I guess, was is the in practice part, in the sense that when you're physically working on near live or potential electricity. But
And I think that's
Mark, I
the message,
love the
though, isn't
wrestle.
it? That's
I love wrestling. He's
the real
a vocal
message.
guy. I love the way he pitched me yesterday.
The real message is to take the risk away.
Yeah, you're right. Yeah,
It is
absolutely
And
right.
if anybody takes anything from
Yep.
this conference,
You are
it's
right. You are
that one
absolutely right.
thing.
And furthermore, I want to really make a stress point. Sitting there, I was probably cringing a little bit. This sounded almost a bit like a sales pitch from these guys. The key thing is, from our perspective, we don't give a crust where anyone is buying any kind of protection from. That is absolutely not the reason of this event. The key thing is that we are doing everything we can to remove and mitigate the risk of an arc flash. And if everything else has failed, which unfortunately things do, is that your workers are going home safe and protecting. The simple message is, if you have the right kind of PPE on, it's your last line defence absolutely in your consideration hierarchy, but the likelihood is that they will absolutely go home safe.
100% agree.
Pastor Martin.
Okay.
There's no at the front here.
If I can add one comment to it. Look at it from the electrician perspective. You are not buying PPE, you are not improving the system, you come to work. So PPE is the last thing on the hierarchy of controls to consider. Doesn't mean that it doesn't work, it's just the last thing because we don't want to use it at the end, technically. That's what you want. But from the personal perspective, it's the first thing you wear. If you will go to work, you just wear PPE. You will not change PPE during the day, most likely. Maybe you can add something into it. This is getting complicated when you get in the service or contractor business because you actually hit multiple different sites, which is not really well documented. So just to give you something like from the other side, if you look at it.
Okay, can I just throw one in there, Angus? There is some of the questions that come through, and that's picking up around going to a customer's site. Graham, I'd really like to throw that
Yes,
one to you.
this is, were you talking from the balcony yesterday? That was brilliant. I appreciate your engagement. I felt sorry I was kind of shutting you down, but here's the floor for you again.
Thank you. I think from Anthony's video at the beginning of his section where you showed the event where the guy wasn't interacting with the switchgear, nobody was doing anything to it and it still blew up. So what this is an insurance. So you don't buy insurance on your house waiting for your house to burn down. It's just in case. So why not wear it?
Absolutely.
Yeah. Okay. And that's the same reason we wear a lot of PPE. It's the just in case, it's the insurance. So there's two more over here, one on the front here, Angus as well. Okay. Yeah. Two down. Yeah. Just one moment, Mark. Just got one here.
I think I'm actually reiterating what's really been said now out of this conversation that's just gone on, in the fact that, yeah, it is last line of defence. At the end of the day, yes, we're wearing this kit. I do HV switching, and I'm wearing the kit. I may come out of it alive, hopefully, but I don't know what mental scars would be, forever then, maybe. So do you really want to be in that situation where, yes, you walked away alive, you're still there for your family, but you don't want to ever do that job again? Mm-hmm. Yep. And that's something that I always emphasize to people. Yes, we get rid of that risk before we actually put the PPE on. And the PPE is there for the residual risk.
Correct. Okay.
What's left over at the end of the day of the control measures, the other things that you put in place.
Part of the overall program.
Yeah.
At the end of the day, we'll never remove all the risk. The only way we remove all the risk is to switch everything off and we all go dark. We can't do that, so there will be that remaining risk. How do we manage that? PPE is one of those mitigations. Simple as that.
I think Mark was going to say something.
Yep.
Yeah, just firstly, I don't term it as PPE. It's an engineering control. So if you look at it like that, not in PPE, it's not your last line of defence. Any study that I've done on electrical incidents happen when the operatives either believe that the system is dead and carry on working, there's a system fault, or there's a switching error. Those are the things that, with all your rules, with all our rules, I grew up in DNOs, so we have our Bibles. But these are the things that happen. And any electrical injury is a life-changing injury. So you put on a scuba suit when you go scuba diving or go diving. You have to look at it as an engineering control, not PPE.
Well said.
Okay.
Back to you again, Richard. You don't need the mic.
No, I probably don't. Just want to pick up on the point now that Kevin brought up. I was on a site about 8 years ago. We had an engineer who was taken to hospital, flown down to Salisbury because that was where the mains burn unit was. He received electric shock. He's a mechanical engineer reading a pressure gauge, but he touched a piece of equipment that wasn't at the same polarity as the pipe work he was looking at, straight across his heart. The only reason he's alive today is because he actually had 3 kidneys. He didn't know that before this event. The toxins that were generated from the shock, which to help protect him, then obviously clogged up. And for the rest of us, we'd probably been classed then as electrocuted. The bit about that, and the bit I want to highlight, is the fact that it took about 12 months for the recovery process. He comes into work and he won't even touch a computer because it's got electricity in it and he doesn't want to get and go through that shock again. The mental side of any type of incident far outweighs sometimes. And it's not just him, it's his family and his work colleagues that are affected by it. And that's the bit we should be really concentrating on as well, to prevent these accidents and doing the utmost that we can to stop people going through that.
Good, thank you.
Okay.
Can we move on to these questions as quickly as possible because the next panel needs to be on because one of the panellists needs to catch a flight as well. So,
Okay. Do we want to stop the questions here and take them later, or do you want to do some of the Slidos, Angus?
maybe just run through some of the Slidos
Yeah,
quickly.
so we've got some of the Slidos one. I'll just pick some of the top few there. I think, Graham, one really for you to start with. We're sending engineers to customer sites to fault-find control systems in LV systems. We don't know what that arc flash level is. We don't know what the incident energy is. How do we proceed from that?
Basically, I sort of covered it when I was speaking there. We can use the tables from the documents that are out there, NFPA 70E, CSA Z462, the European Arc Flash Guide's got some fantastic tables in there as well. Also, there's an online one as well, which is a fuse table calculator, which spits out data very, very rapidly and quickly. Alternatively, I mean, been doing this that long, I've got a stick drive full of studies, scenario bases, so typical transformer sizes, typical, I'll run using ETAP, I'll put certain levels, different sizes of transformers in, different protection, ultra fast, blah, blah, blah. So I'm coming up with an approximation, never as good as a full system study, and they're not always right either because of scenario bases within the studies, but also there's calculators, there's apps on our phone, or we go old school and use the calculations as you shared yesterday.
Yeah, basic calculations will get you the same answers.
But the apps are great, transformer impedance is there, it's not always difficult to find transformer sizes, it's usually, if there's an SLD, it will be on there, or, do you know what, go for a little walk.
Go have a look at the equipment.
That's what I'm saying, it's on site, go and have a look at the data plate, and so within half an hour, the time that you're getting all your gear out of the lads are getting the gear out of the van and establishing something, we're doing a point-of-work risk assessment, and we're collecting the data. It gives us that time to stop and think about, right, what's going on, what's wrong, why we're here anyway, why have they called us out at bloody 11 o'clock at night? And we can very easily put together a safe system of work within the room, within that specific task, very, very quickly. And we've all got our gear with us anyway.
Okay. All right. Thanks, Graham.
Hope that answers it.
Yeah. Anthony, I'm going to ask one for you here. ATP value is shown on all presentations. And in that, there's a calculation that it's a 50% chance of second-degree burns. Why don't we use the elimination value rather than that 50% value?
So when instant energy is calculated, it's an instant energy at a given distance from the switchgear. Okay, that instant energy, that's not ATPV, it's not EBT, it's not ELIM, it's an instant energy. PPE is then rated in either ATPV, arc thermal performance value, EBT, energy breakthrough threshold, or ELIM, so basically elimination. So originally, open arcs were done, the testing was done in the USA on an open arc circuit, and the testing always gave two results, either EBT or ATPV. You've got to advertise the lowest of those two ratings, okay? So it's either energy breakthrough, so your actual fabric is broken open, but the thermal effect hasn't actually affected the calorimeters inside, or the calorimeters inside are reading rating higher than the stall curve before the fabric's broken open. That basically tells you ATPV, the fabric still stayed intact. The actual instant energy rating has met the stall curve with the fabric intact. EBT is when the fabric's opened up before it's reached the stall curve, but there's still no burn or second degree burn there. ELIM was bought in, it's only used in Europe, it's not used anywhere else in the world. It was used in Europe because originally the traditional method in Europe was a closed box arc test, or arc in a box, often classed as. Arc in a box is really, really prescriptive. 4KA, 7KA, 415 volts, 0.5 seconds. Okay, so really, really prescriptive. It's in a box, completely different set of how the actual arc flash responds compared to an open arc. Open arc is three panels in an open arc. The 50% probability of a second degree burn was generated because you can't always guarantee that somebody is stood the exact distance away from the actual equipment itself. Adding to that fact, if I tested a piece of fabric today and tomorrow and the next day, 2 weeks' time, a month later, I'll get a different result from my fabric every single time. Okay? We constantly test fabric. If I use ELIM, I'll get a different rating tomorrow for ELIM than what I got today. I'll get a different result next week. So ELIM is basically saying that this cal rating for Elim, you're not going to get burnt, okay? In reality, the fabric on the next batch, you might get burnt because it might be actually quite a bit lower. So the 50% probability builds in the area of caution. Plus, when we test fabric, so when you get an Elim rating or an ATP or an EBT in the fabric, that's the rating of the fabric directly next to the calorimeter behind it. So the arc flash is generated, the arc flash heat hits the fabric, goes through the fabric, and it's the time taken for the calorimeter to reach the Stoker burn unit, device. So ultimately speaking, you've got no air gaps. When we wear clothing, we're wearing clothing with air gaps. I'm wearing a shirt now with a placket. I've got double layers of protection. If I double the fabric, I normally always increase my fabric protection by double. So in reality, we always actually have more protection around us than the label will tell us on our sleeve or inside the garment. So Elim, I very rarely refer to Elim. I refer to ATPV or EBT. Ultimately speaking, 50% probability of second degree burn or the onset second degree burn, you're likely to be less than that. So if your garment says 12 cal, you're more than likely protected against 14, 15 cal. When a garment is tested, if the label on the garment says 12 cal, the garment will be tested at least 12 cal, 13, 14 cal, to make sure that the garment is going to withstand the arc rating. As you saw in the video before, 12 cal garment, 14 cal arc test, okay? So in an actual garment itself, as a made garment, you'll get higher protection levels than what the actual garment label says on itself because of the way it's tested and then the way you wear it. So 50% probability is right because fabric changes every single day. Elim is Elim today, MOT day, okay? Tomorrow, it might not be the Elim rating you've got on the garment. So to go back Elim is a bit of a myth. It was brought in to kind of match up with the pass or fail situation with the closed box arc test. Class 1, Class 2, pass or fail, no grey area, no in between. A cal rating gives you a defined protection level for the clothing you're wearing. So Elim, if I had my way, I'd reroute that rule and just keep it like the USA keep it, ATPV or EBT.
Okay.
Hope that helps.
Thank you. No, that's good. There's another one that I think is going to probably come your way as well. Sorry, we've got a question.
I'm really concerned for the maintenance of safety that Andrea can catch up.
Okay, we'll draw a line to that, and as we sort of say, we'll talk to the panel after, we'll do the questions from there, and we'll put that out on the video. Just one thing for Victoria, praise for you, thank you for being an advocate for women's clothing in there.
Thank you.
So, yeah, good praise on that one. All right.